Good afternoon. How's everybody doing? Lunch? You're not hitting the snooze button yet because we've got some really interesting conversations planned, and hopefully you will enjoy hearing from some of the more interesting CEOs that are living and breathing AI infrastructure. So this panel is going to be on rebuilding AI hardware for the inference era. As you know, everybody has been talking about training for the last several years, and now we're really in the thick of inference. So there are no better set of companies to talk about that than the ones that we're going to have at this panel. Allow me to introduce Abhi Ingle. Abhi, come onto the stage. Rajiv, Khemani, and Barun Kar. Abhi, come, please come. So we're going to have a conversation with these three gentlemen about some of the problems that they are trying to solve. Abhi is from SambaNova. As you know, SambaNova is one of the pioneering inference full-stack businesses that Celesta has had the pleasure of being associated with right from day one. Rajiv Khemani, he wears multiple hats. As of yesterday, he is the chairman of Upscale. I mean, he's been chairman of Upscale for quite some time, but the Upscale has been in the news fairly recently. And he's also the CEO of Velaura AI. We can talk about that. And then Barun is the CEO of Upscale and a veteran in the networking space for the longest time, having been part of the founding team of Palo Alto Networks. So with that as the backdrop, if I may request each of you to just spend a minute to talk about your respective companies. Abhi?
So SambaNova delivers full-stack AI systems built around a chip that is purpose-built for inferencing, and it uses proprietary technology to minimize the flow of data. And the net result is, I think, 3 to 5x the inferencing speeds, 2 to 3x the energy efficiency, and the ability to operate in air-cooled environments in existing data centers.
So I'll talk about Velaura. Velaura AI, we offer a unique design and IP platform for ultra-low power. And we apply that to a variety of XPUs and AI accelerators and bring the power down of the mathematical units by up to 4x, resulting in the power coming down by up to 2x of the overall chip. As you know, power is super important. And we are applying that to a variety of chips in both the data center space as well as in the physical AI and edge space.
So at Upscale AI, we are a pure play AI networking company focused on democratizing AI networks, or AI in particular infrastructure. And this we do by delivering high bandwidth, open standard based, low latency networking products.
So with that as a sort of the backdrop, let me start with Rajiv, with you, since you have your hands on very many pies, as it were, in the AI infrastructure. The key point to start off with is that inference has gone from about 1/3 of the overall AI compute spend to over 2/3. And some of the analogies that people have used is that what you saw above the water on an iceberg is training, what you don't see is inference. And much of the actual compute workload that happens, nobody actually sees. So when each of the queries that we make today is now costing 100x, if not 1000x, more compute capacity, there's a big question around unit economics. What we originally started out with in the build-out of the training infrastructure and the economics calculus that we used to have, they don't apply anymore. And so can you talk about, is the unit economics assessment as we did before, is it valid anymore? Do we need new set of metrics? What is the way to think about it?
Yeah, I think that, so it's a great question, and it's a pretty big question. Clearly, all of us want better economics, but then what we are also seeing in the market is that AI compute is becoming more heterogeneous and segmented, and in some cases disaggregated. So in the case of inference, clearly there's a class of applications that want very low tokens per watt, and so power is an important aspect, but also specialized AI compute is becoming an important aspect of that. And so I think that's one big part of this story. Clearly, there are applications that are willing to pay more, and they want better tokens per second, for example, and willing to pay more power and more dollars to make that happen. But I think we'll see segmentation. So whether it's a user writing a prompt or an agent doing something or a batch job or a customer service type of an application, you'll see different kinds of AI compute. At Velaura, what we are focused on is, can we bring the power of this compute down across the board, right? So regardless of what type of compute you're using.
Yeah. So actually, before we get into the power and how you're doing it in Velaura, maybe Abhi, I can't help but look at how your parents have been so foreseeing of the era that you will be working at and named you AI. That's your initial. So who better to answer this question on AI? So the training infrastructure, which is what we all today even use for most of inference, arguably is very inefficient. So is it fair to say that the compute that we are actually deploying for inference actually pays an inherent training tax unless you yank out all of that infrastructure and put new infrastructure for inference? How should we think about it? Where is that bright line between where training ends on a particular infrastructure and where inference starts?
Okay, it's a great question. First and foremost, training is a cost center. Okay, inference is where you actually make the money. And if you look at the charts that you just are showing here, right, today's defining workload is inference, in particular agentic inferencing. Most of the deployed infrastructure is essentially designed for compute-heavy training, right? While the task of inferencing is essentially minimizing data movement. And that's precisely what SambaNova does, is its architecture is designed for reducing data movement. So one of the things you can do in this scenario is actually combine NVIDIA GPUs, which are the predominantly deployed modality in the market. You can combine them with SambaNova's data flow architecture. And you just demonstrated this at Computex. We're using those two architectures together. Prefill in inferencing done on NVIDIA, decode, which is the process of generating the tokens, which is what you want, done on SambaNova. And we sped up the models by 2 to 3x on our existing generation chip. For the next generation chip, it'll be like 5x.
This is an interesting point that you're making, because it is not just in the GPU where there is a need for clear segmentation and a bright line of separation between prefill and decode. Because if you actually look at the whole infrastructure, there are so many subsystems. And Barun, you probably are best qualified to talk about this, because people forget that when you have scaled systems, the missing piece of tying all of these things together is really networking. Some would argue that in decode, which is a memory-intensive operation, overall you could make the comment that it's all a networking problem. Now you're basing this new company, Upscale, on that fundamental premise. So can you talk about what is the statement of the problem in the scale-up architecture that you're trying to solve?
Yeah, so I would say networking is the most important piece today. Both these gentlemen spoke about inference and inference cost, and inference cost is directly proportional to memory and to latency, right? Inference cost is proportional to the capacity of memory, to the bandwidth memory, bandwidth of memory bandwidth, and the latency. And the most important piece, of course, we feel is the latency piece. So essentially, if you now look at, you're trying to divide, like you mentioned, prefill and decode, and especially if it's a reasoning kind of a model, that's where like your decode portion, because of the auto-regressive nature, it explodes, right? And that's where latency becomes a bottleneck. Okay, so it's very important to have a networking infrastructure in that situation, which can deliver, microseconds or nanoseconds of latency. In fact, there was an NVIDIA research paper which said that in order for high bandwidth memory to synchronize, you need less than 1 microsecond of latency to better, tokens per second.
Well, but implied in your answer, you have not stated it out explicitly, is this belief that the current implementation on networking, which is NVL72, what NVIDIA currently uses, and they are 98% of the market, and so inherently you're making the bet that there are going to be alternate approaches to stringing together these various blades within the data center in the rack. Why do you think that is needed when existing Ethernet or some version of InfiniBand that you could possibly use for scale out? Why could that not have been the right approach? And if the answer is yes, then why not existing guys, the incumbents? Why would they not be in a better position to do it and they needed an upscale to come and shake the apple cart, as it were?
Yeah, you want?
Yeah, I mean, every time there is a new computing paradigm, there's a new networking need for new networking, right? And so in the early days of PC, you had Cisco and Juniper that built the network. Then in the cloud, it's been predominantly Arista and Broadcom. Now, the challenge is that the networks that have been built have been predominantly for the front end, which is connecting servers and storage to each other. We are now talking about connecting GPUs and XPUs to each other. Very different use case, right? In the front-end network, it has been packet-based traffic. We actually rely on the TCP protocol to take care of any inefficiencies that exist in the network. And we are able to tolerate latency much more. In the back-end network, as Barun explained, latency is critical. And in fact, jitter is very penalizing. Tail latencies are very bad, cause lots of delays. And so the thing is, you can't simply tolerate that. And the characteristic of the workload is that you're doing reads and writes. So it's a memory-based semantics in the back-end network. Now, every time there's a new paradigm, people use the products from the previous paradigm to cobble up something, right? And that happened in the cloud. The first versions of the cloud really used enterprise telco gear until purpose-built cloud solutions happened. Same thing is happening here. In the first version of AI networking, a lot of the people are cobbling using front-end networking capabilities, but you really do need these purpose-built solutions. In some ways, you can say NVIDIA with the NVLink is ahead of the market on the scale-up aspect. But even in an NVIDIA cluster, you need Ethernet networking, which is scale-out networking to build very large clusters, right? And that's happening. Again, you need purpose-built silicon systems and, equally importantly, software to make it happen. And so that's kind of where we are focused on in Upscale.
Well, I want to push you a little bit here because, while I agree with your point that with each new paradigm in computing, there's always a new networking innovation that happens. You had token ring and Ethernet and X.25 and ATM and a whole bunch of things. But the industry sort of got over all of it, and it became Ethernet. Ethernet became the winner, right? I mean, within the infrastructure of the data center, it's 10 gig, 100 gig Ethernet. So why not have that as the fundamental architecture for both scale up and scale out?
And by the
people
way,
in the audience, you might want to explain the difference between scale up and scale up.
So very simply put, scale up is connecting just to simplify it, GPUs inside of one rack. Might get to 2 or 3 racks, but inside of one rack, connecting them to each other. All the GPUs are connected to each other through a switch, and they can access each other's HBM memory or other memories that they might have. So that's scale up. And then scale out refers to the fact that you want to take these racks and put hundreds and thousands of these racks in a data center, and you need a network to connect those, okay? Now, the point about Ethernet is an interesting one, and I think people are somewhat, I would say, ignorant to the fact that Ethernet, even though we use the same word Ethernet, Ethernet actually has evolved quite a bit. Many, many years ago, when Ethernet started, it wasn't a switch network, right? It was a shared network with a very lossy characteristic. Then it evolved to be a switch network. In more recent years, there are protocols, and it was actually a lossy. Packet drops were tolerated. But then people came up with these protocols like RDMA and PFC and whatnot to create lossless capabilities. Now, the Ethernet that's used inside of a switch versus Ethernet that's used in a WAN router is quite different in terms of buffering and quality of service and queues and all that. So even though we refer to Ethernet, as a single word across, tens of years, it has evolved. Now, the good news is it's also evolving for the scale-up world, and now there's a new protocol or a new industry standard called Ethernet Scale-Up Network, which is again morphing Ethernet for the use case of scale-up, and of course scale-out as well through the UEC standard. So clearly, Ethernet is, and there are advantages to call it Ethernet and refer to it as Ethernet from a management point of view, a familiarity point of view. But Ethernet is evolving to address the specific requirements of AI backend networks.
So I'm going to ask you to speculate here,
Yeah.
which probably you're not going to be comfortable with. More recently, TPUs that Google had were finely tuned for GCP, Google Cloud, and doing Gemini as the inference model. And now, as obviously we all know, Google has opened it up, and there are a lot of others that are trying to standardize on a TPU infrastructure. So here's the speculation part. Do you think there's a scenario where NVL72, which is now fine-tuned for Blackwell and Vera Rubin and all of that, is there a scenario where NVIDIA says, well, why don't I just make it all open for other GPUs to plug in? And if not, why not?
I think NVIDIA is already making steps in this direction. Certainly there's some initial steps they've made where they have brought out the NVL Fusion, where they're allowing other compute vendors to plug AI compute into their racks. So that's already happening, and there's more stuff that that is being discussed, still in the early stages. But I wouldn't be surprised if NVIDIA makes it more open. So they are moving in that direction because I think NVIDIA is also recognizing that the world is not going to be one type of compute everywhere, right? And there's opportunity for specialized compute, and the Grok acquisition really is a testament to the fact that they have embraced a different type of an AI compute in their overall architecture.
Which is a great segue to what I wanted to ask Abhi about, because I think the way NVIDIA went about actually looking at what Grok has as a perfect complement was because they were able to segment the inference workload into prefill and decode. Now, historically, any compute has always been measured on flops, right? How many floating point operations per second you can do, and that became the metric. Now, as we've sort of briefly touched on, dollar per token per watt per user seems like that seems to be the right metric. In a situation like that, is the value proposition that SambaNova brings, is it on raw horsepower on that metric, or is the ability to actually stitch together the entire, end-to-end rack with possibly a model on it for sovereign purposes? Where is the differentiation for you if it is not just, raw speed or performance in that level?
So you asked about the metrics. I believe the defining metric will be intelligence per joule. Okay, and intelligence has a lot of elements to it. It's not just raw speed. Okay, it's also the size of the model oftentimes, right? So the key to essentially agentic inferencing, right, which is where you essentially complete a task and actually derive value, therefore having money to invest, depends on large models that are executing very fast. And if you look at some of what SambaNova does, we call those premium tokens. Even Jensen talked about this at GTC, where his presentation miraculously changed from last GTC to this GTC, with Grok defining a level of intelligence for that speed. But all of those choices that you have are making you make trade-offs. You can either have scale without speed, which is the GPU, or you can have speed without large models, which is Grok. Okay? With SambaNova, you don't have that trade-off. You have large models executing fast. You can also have multiple models because if you look at an agentic inference, you could have multiple models making calls. And when you have multiple models calling each other, every inefficiency you have, every slowdown you have compounds on a training-led infrastructure. That's why I think that's where SambaNova really distinguishes itself, right?
Well, I thought you were going to also say something related to sovereign, because if I were a sovereign government that I'm looking at deploying, I want to be hardware agnostic. I don't really care whether it's a NVIDIA GPU or Cerebras or Grok or anything else. I want to have a, best of breed, if you will. Just like the way we have MOE for the models, why not have a best of breed of hardware? And I thought the fact that you could actually offer a solution which allows for sovereigns to do that, is that even in your calculus, or how are you being perceived in sovereign markets as you go into those markets?
Absolutely. We have 4 or 5 different sovereign clouds being built on our architecture for the very same reason that you mentioned is, if you think about what you would have to do to get an alternate architecture, you need hundreds of thousands of racks. You can do that in a relatively small number of racks consuming relatively low amount of energy, right? That's one of the benefits of SambaNova's data flow architecture and 3-tier memory. So you could have like one rack of SambaNova running 3 or 4 copies of DeepSeek, which is then now customized by that sovereign government for their own purpose, right? Or it could be GPT-OS as, basically fine-tuned for a particular country's context. And all of that can run on SambaNova in their existing data centers. Unlike the US, if you look outside the US, there's a paucity of data centers, there's a paucity of power. And that's why SambaNova plays really well, because you can have a large number of models in a small footprint running very efficiently. Okay?
Well, you touch on an interesting point, because intelligence per joule or cognition per joule, if that's the right metric, we don't spend enough time talking about the joule part of it, because now everybody is talking about a gigawatt data center, and you could have a couple of hundred megawatts in a rack. So, Rajiv, I really want to have you comment on this, because the data center power is on track to double again by 2030 to roughly, Japan's entire energy consumption, just in one fell swoop. So when people think about power, it's not just the power that feeds the rack, it's also what happens at a component level, whether it is power management for all the ancillary chips that are there, or even the core GPU that's there. Now in Velaura, you have a long history. You came from the Bitcoin blockchain space, and so you had to really work through taking a workload and spawning it off to multiple GPUs. What did you learn from that has become applicable for you in the AI space? Specifically, you're trying to make that available for all kinds of GPUs. So talk about what Velaura does in that context.
Yeah, we started out trying to reduce the power of Bitcoin chips, and that is like an extremely demanding application, because every milliwatt of power, it translates to money. Okay? So it's a very pure problem to solve. And what we obviously were faced with is the physics of building semiconductors. And the way we started from first principles, where essentially power can be defined through a very simple formula, which is, alpha CV squared F, where alpha is the switching.
Are you just testing if people are awake?
This is a homework assignment for everybody, if you can remember it. But it's like, how much are you switching? What's the capacitance? The square of the voltage times the frequency. That's the power that you have, especially the dynamic power in every chip. And so, the obvious one is, if you can bring the voltage down quite a bit, you save a V squared in power, right? And so, sounds very simple on a math formula. It looks very easy, but the minute you bring the voltage down, the way semiconductor manufacturing works, reliability goes to hell, yield goes to hell, your frequency drops because you're unable to achieve the frequency. And if you want to achieve the same performance, you need much more silicon area to do it, right? And so what we spent multiple years was trying to crack the code on that, and can we recover all of those things while keeping the voltage down? And we've done lots of patents in this. We've done many chips at leading edge semiconductor nodes. And we came up with this technology, which consists of obviously our physical design flow, or we kind of do hand placement of these transistors on silicon, and then create some custom arithmetic libraries. And we've been able to bring that power down by 4x or more, actually, in some cases. We did that in the context of Bitcoin. And when we saw the world moving to AI and AI consuming 10x or even more of power relative to Bitcoin, we felt like there was a use case over there. And that's when we pivoted. We actually have been working on this for over a year now. We have like 3 hyperscalers we are working with on their specific XPUs, where they've actually given us their arithmetic units. We have actually shown them over approximately a 3x reduction in power on their design, with no change to the software, no change to the silicon, if you will. And so there's a lot of excitement. And I think as over the next few years, we'll roll it out to a broader set of people, which we think is going to be incredibly useful for the world.
I mean, it's one thing to say that you can bring out the best-in-class performance power ASIC to the market and go head-on with an NVIDIA or Cerebras or somebody else. And the other side of that is to be able to say, I'm just going to be picks and shovels. I'm going to give you IP. All of you can, take advantage of it. So your model effectively presumes that everybody's your friend. They all want you. Is that?
Yeah, we think that the data center AI compute space, there's a lot of choices people have, and there's a lot of brilliant ideas and a lot of different designs that are being worked on, and they're purpose-built for their specific use cases. So to be yet another provider of data center AI compute, we felt was a little too late situation. And then why would we limit it to just our chip in the data center space? And so we basically are providing that to a select set of customers. We can't handle too many customers, but we're providing it to people that are interested. And then we believe that this has applications in certain chips that the world has not yet built, and we could
Such as?
I mean, we think that there's a future in physical AI that is still emerging. It's very early days in physical AI. The market is still very small. I think it's going to be very massive in the next decade. It will get segmented, similar to how it's been segmented in the data center space, as we just spoke about. And I think there's opportunity to build some really compelling chips. The interesting thing about physical AI is that power is even more important, because these devices are not plugged into a wall, and that battery life matters. The other thing is that these devices can't get hot. I mean, inside of a data center, you can do crazy things like liquid cooling, but you can't do it in a device that's a physical device in your home or in the factory. You can't have liquid cooled devices walking around. It's a big challenge. So some of this technology we think has even stronger applicability in those areas.
Yeah. So this leads me to an interesting question, which I think, Abhi, it'd be great for you to comment on, because the capex on the hyperscalers is nearing almost $1 trillion per year, right? I mean, this is, 725 billion capex in 2026, and that's a pretty big number. And this does not compute, pun not intended, what the sovereigns are planning to spend, because if you believe that sovereign requirements are going to require the data to stay within the sovereign geographies, they need a completely new infrastructure. That part of the market is yet to be defined as to how much Saudi Arabia is going to spend or UK is going to spend on others. So when you don't have a handle on how big the total available market is, how do you operate? Because your whole business is anchored around not hyperscaler incorporating your technology, but sovereign and some large laboratories and enterprises and all of that. So how do you think about the market in that context that SambaNova sells into?
The size of the inference market that you're showing is so large that in some ways, we look at that and saying, we are going to take a portion of the market that is focused on what we call premium inferencing. Okay? We don't try to worry about the size of the entire market out here, simply because the market is so ludicrously large, right, on that particular front. We try to kind of meet customers where they are and saying, what are the problems that they have today that are being solved by the existing infrastructure? Okay? And what are the ones that they're making compromises on? We know they're making compromises on speed. We know they're making compromises on large models. So we focus in on those, right? And we're very comfortable kind of being centered on customer needs. So we'll complement NVIDIA in certain situations. We'll be the main solution in certain situations, right? And that's sort of our approach, which allows us to basically build in a very steady cadence as our chip generations kind of compound, right? We reach a larger and larger surface area, but we try to stay focused on big models running fast in a very, very efficient manner. Chips are air-cooled, right? Low energy footprint. We try to stay very true to who we are and not worry about trying to chase every single segment in the market.
You know, I want to push you a little bit just by way of comparison to the old compute industry where you had PCs and you had the Compaqs and the Dells and the IBMs and Lenovo's, and they were all buying stuff from x86 and slapping together Microsoft software, and they effectively became packaging companies, right? And over a period of time, they all disappeared, right? There were one or two that were left. So what is your mental model when SambaNova brings up a full rack, Cerebras has a full rack, Grok has a full rack, Velaura, possibly at some point in time if you're focused on the physical AI. So what is the industry structure that you think that you're going to be selling into? Are you envisioning 5 or 10 of your competitors going after the same sort of a market space, but differentiating, as you said, based on the type of model you run, or how are you going to be able to differentiate?
Well, from our perspective, right, first of all, we're not chasing, as I said, the whole market. And even in inferencing, right, let's disaggregate the market, right? NVIDIA is really great for what I'll call compute-heavy tasks like training or the prefill portion, right? You take some of our other competitors, they're making trade-offs. They're SRAM-only chips, okay? So there's only a certain amount of size of model they can run at a certain speed. And that fundamentally limits their deployment capabilities. That's why they're all behind clouds. They're not on-prem or in sovereign deployments, right? And they take up an ungodly amount of energy because you've got so many different racks happening there. So if we stay focused on our space, I believe that we have a very differentiable space. I think some of the others might have to think about what their differentiation is long term. But we feel very confident about our space being, first of all, growing very fast, because if you look at inferencing, it's growing faster than training. Agentic inferencing is growing faster than inferencing. And within agentic inference, if you look at what's required to deliver the most intelligence, that's fast, large models generating faster. That's where we focus.
I mean, this is such an early time in the whole space, even though it feels like we've been talking about AI for almost a decade now. It's fairly early in the evolution of how these different players are going to grow and become big companies. So Barun, in this context, you are one of the early companies focused on scale up and potentially scale out architecture. But that's not to say that there are not some very strong incumbents in the market. You could take Arista, you could take Broadcom, you could take Cisco, and a bunch of others. Even though they've all have networking background, they've been focused on a completely different workload. So do you think there's space in the market for a company like Upscale, or perhaps even Nexthop, which is potentially a competitor to Upscale, to establish a beachhead, not just because you're first to the market in this workload, but you have enough differentiating capabilities that puts you way ahead of some of the incumbents who have got more money than God in some cases. And how do you compete not in capital that you've raised? Kudos to you. You managed to raise a couple of $100 million very quickly in this period. But that notwithstanding, you have to differentiate at a product level. Is time to market and being first in the market, is that the key advantage that you have? And if not, what are the other places where you can differentiate?
Sure. So you did mention some of the incumbents, but what they have is a cloud era legacy product. And what they will do is try to come to this market with the cloud era legacy product, right? Whereas the requirements for this market, as we are talking about, like inference and training, the requirements is much different, right? For example, inference, like I mentioned, memory, bandwidth, and latency is very important, right? So what are we doing to solve the latency problem, high bandwidth problem, right? And these need a purpose-built purpose-built solution meant for the AI. So what we are building today is, a switch fabric which is meant for scale up, okay? And then there are myriads of different kind of open standards that are coming up. UA-Link, ESUN, NVLink Fusion, like Rajiv mentioned, can come in, we can support all of them. So we are better prepared for heterogeneous compute infrastructure where, like you mentioned, agentic AI is coming in, which needs like orchestration, which needs a different set of hardware requirements compared to inference and compared to training. All of them needs a different kind of architecture.
Yeah.
So in the future, if you get an AI workload through orchestration, you can divide it into smaller workloads, each of them running on a different hardware to optimize TCO.
Yeah.
And we would be providing the open standard-based switch fabric, whereas companies like SambaNova can come in and seamlessly plug in and work together with other companies.
I think the bigger point that you're really making is that some of the incumbents, even though they are well endowed and they have lots of capital and access to market and all of that, they're not purpose-built. I mean, it's the same reason why Tesla is giving a run for its money for all the other automakers. So that I get. But Rajiv, I want to go back to something that you said about physical AI. And we would all agree that the reason why NVIDIA is as powerful as it is not just because of the performance per watt that they're able to deliver or their access or any of that, arguably. The ability to have the CUDA ecosystem where they have 4 million plus developers. I mean, as you know, the developer ecosystem is the hardest to attract and retain. So when you are launching into physical AI in the context of Velaura, or perhaps even SambaNova with your products, how important is it that you're able to have a convincing story for developers to develop on your platform?
Very important, extremely important, right? And so I would say NVIDIA has done a fantastic job at CUDA over many, many years, universities and PhD folks and so forth. So CUDA is extremely powerful, no question about that. So the way we think about it is that for somebody to consider a product that's different than NVIDIA, you need to be purpose-built for a very specific application and use case, right? So if you're building a product that's taking NVIDIA across all segments, I think it's very, very uphill task. And more than likely, you will fail. So I think that picking the segment, making sure that the value proposition in that segment is very clear and compelling is extremely critical. I think the second thing that we will see, I think, in the next quarters in front of us is that AI is coming like a juggernaut. We all know that we have Opus 4.8 and GPT 5.5 and so forth, and we have Mythos class models coming from multiple vendors, I think, in the next 3 to 6 months.
If the government allows it.
If the government allows it, hopefully with some guardrails and whatnot. But these models are extremely powerful in taking code from place A and putting it into place B. And I think that that capability is coming to developers everywhere in the world. Okay? So I think that is something in our future.
Can I comment on that?
Please.
Look, undoubtedly, right, CUDA has a powerful following. But if you look at what's happening, we're betting on open source and open standards, some of which actually come from NVIDIA, right? So if you look at the serving frameworks, things like VLLM, SGLang, what's actually happening in the ML community, it's all PyTorch at this point in time. So there might be a small hardcore core of people that insist on CUDA, fine. Again, like I said, we don't have to hit everybody. Yep. The vast majority of the world will live in PyTorch, and that's where we'll operate. We will basically go after those communities, we'll extend it, and we will basically open source our plugins for our engines into those open source frameworks. If I hit 90% of the audience, I'm happy. I don't need to hit 100% of the audience.
That's great. Well, as we're trying to wrap this up, I have one final question that I want all of you to comment on individually. Each of you have had stellar track record. I mean, Barun, you were one of the founding members of Palo Alto Networks, which is a greater than $100 billion company. Rajiv, you took Cavium public, and you became an iconic company that Marvell acquired, and arguably lots of what Marvell does is built on that foundation. And Abhi, you were at AT&T for almost 2 decades, and you were involved in lots of innovative companies in your career. And like all of us, you've all had other not so successful things in your career as well. So as you're embarking on this wave, and you're all working on some very fascinating opportunities. What keeps you awake with respect to your company and with respect to the space? Abhi, you want to go first?
I think it's the speed of change. The speed of change in this, I've been through like 4 or 5 different technology revolutions. I think we talked about that, Sriram, before. You seem to have known people through every one of my steps out here. But the speed of what we're seeing is incredibly, incredibly mind-blowing. Yep. And so having a team that's super aligned, incredibly flexible to match how customers are changing, right, puts an incredible premium on execution. I think that's what keeps me awake, is making sure all those things stay in balance.
Right. Rajiv?
Well, personally, I have no problem sleeping, so I don't stay awake. But I think, honestly, I used to stay awake many years ago, but now I sleep well. But I think the key thing to do is that there is change happening. You can't build a plan and just stick to it. The world is moving and changing too fast. And I think the combination of like an amazing team, some foundational differentiation and technology, clearly amazing investors, including yourself, and then just staying, ability to change and pivot. Mm-hmm. You can keep doing that, and I think it's a good fun in this. It's an amazing time to be building.
True that. I think having known you and seen and being part of the pivots that you've gone through, the one thing that I know you will do is be willing to change at a dime. So I know that firsthand. And Barun?
Yeah, so one thing I feel I'm paranoid about is what are the best practices that are out there for AI, yeah, and how we can increase productivity, right? So like he mentioned execution, right? I mean, is there something out there today which can change my productivity 10x? And also how to scale the organization accordingly. Yeah. So these are the two things which I'm paranoid about.
Well, gentlemen, all of you are building some amazing technologies in an amazing time in our lives of this huge disruption. We at Celesta are just privileged to be involved with you almost from day one in each one of your companies. And so good luck to you and wish you great sleep in the night, as Rajiv points out. Thank you very much.
Thank you.
Thank you.